So far we have discussed about step number 3. Step number 3 for finding the denominator as well as numerator value of h of s. Then we could able to have the procedure, that is step number 4 in Butterworth filter design. Calculate the value of cutoff frequency, that is analog cutoff frequency ohm. Ohm always represents analog and omega always represents digital frequency. In that we may have two formulas for finding out the cutoff frequency. From the passband frequency also we could find out the cutoff frequency. Ohm suffix p which is given, then we could able to select this formula, ohm p divided by 10 to the power of 0.1 alpha p minus 1 by 2, that is whole power 1 by 2n, where alpha p is nothing but passband attenuation frequency and n is nothing but order of frequency. If suppose stop band frequency which is given means another formula, that is ohm suffix x divided by 10 to the power of 0.1 alpha s minus 1 whole power 1 by 2n, where alpha s is nothing but stop band attenuation frequency, that is stop band attenuation constant, and n is nothing but order of the filter. Then from after finding the cutoff frequency, we could come to the final step, so called analog transfer function, that is analog transfer function h a of s, that is h suffix a of s. So far for finding the h a of s, these are the following procedure which we were followed in Butterworth filter design. At last for finding the transfer function h a of s, h a of s is nothing but numerator. So far we have find the h of s, in that we have numerator value as well as denominator value. In that wherever you are getting s value, that s should be replaced by s divided by cutoff frequency, analog cutoff frequency. Then the transfer function what you are obtaining is nothing but analog transfer function, analog transfer function. This is the overall procedure of Butterworth filter design. After finding h a of s, the analog transfer function, then you are requested to find out the digital transfer function. Digital transfer function is nothing but h of z. For finding h of z, we could be able to, from h of z, we could be able to have two following procedure. One is bilinear transformation method and the second one is impulse invariance method. Impulse invariance method, IIM, impulse invariance method. So the next Butterworth filter, so far it can be concluded. The following 5 design procedure which could be adapted to find out the analog transfer function of any Butterworth filter. Then the second method, so called chebyshev filter design, we could have 6-step procedure to find out the analog transfer function of any IIR filter. For finding out the chebyshev low pass filter, the following design procedure to be adapted. The step number 1, here also we could be able to find out the order of the filter n, but the only change in from the previous Butterworth filter is there we could be able to have log of the formula. Here we could have, while we are adapting Chebyshev filter design method problem, for finding out the order of filter n, hyper cos, that is in the calculator you need to press hype, then shift, then cos. If suppose you are pressing hype, shift cos means it could be able to have cos h inverse function. From that cos h inverse function, 10 to the power of 0.1 alpha s minus 1 divided by 10 to the power of 0.1 alpha p minus 1 whole divided by cos h inverse ohm s divided by ohm suffix p, as well as the given specification which is not directly given as alpha s as well as alpha p, then the AP value as well as AS value which has been given means AP and AS, that is straight away the magnitude of stop band frequency as well as magnitude of stop band frequency which is given means, then we could able to adapt the second formula so called that is cos H inverse of lambda divided by epsilon whole divided by cos H inverse of ohm S divided by ohm suffix P, where A suffix P which is equal to 1 divided by square root of 1 plus epsilon square, and A suffix S equal to 1 divided by square root of 1 plus lambda square. From that we could able to find out lambda as well as epsilon value. Then the step number 2, here also we need to round it off as like the previous Butterworth filter design problem. Here also we need to round it off the order of filter n into the next highest integer. Step number 3, here we need to find out the A and B value constant. Why we need to find out A and B value constant means, in the step number 4 the poles of the Chebyshev filter transfer function we need to determine. For determining the poles of Chebyshev filter design we are in the need of A and B value. For finding out the A and B value that is pole constants, A value which is equal to ohm suffix P into mu power 1 by n minus mu power minus 1 by n divided by 2, where mu is the constant, mu is derived from epsilon inverse plus square root of 1 plus epsilon power minus 2. The epsilon value could be obtained from 10 to the power of 0.1 alpha p minus 1, or it could be arrived from this procedure also, that is if the passband that is magnitude which is given means, here we need to find out the epsilon value. If suppose the passband attenuation constant which has been given, that is alpha p which is given means, from this formula we need to find out the epsilon. That epsilon we need to substitute here, and we could able to find out the mu value. After determining the mu value, you need to substitute here, and n is nothing but the order of the filter, and ohm suffix p is nothing but passband frequency in the form of analog. Always every time as I am repeating that alpha, that is ohm represents analog frequency, alpha represents attenuation, passband attenuation or stop band attenuation, and omega represents digital frequency, as well as AP as well as AS represents magnitude of passband and magnitude of stop band. So these are the constants. From there we could able to find out the A value as well as B value, and B value is nothing but a ohm suffix P mu power 1 by n plus mu power minus 1 by n divided by 2. From that, after finding the A value as well as B value, you could able to substitute in the step number 4 to determine the value of denominator of the transfer function, S suffix k, where S suffix k, the k value extends till n value. If the n value you are getting as 2, then it extends up to 2. So based on the order of the filter which is available in the first step, whatever the n value you are obtaining, k till repeats. So S suffix k equal to A cos of phi k plus j b sin phi k, where phi k equal to phi k is also the k value here also extends till order of the filter n. Here pi by 2 which is in the form of always you could able to substitute here it as radians value, pi by 2 plus 2k minus 1 divided by 2n pi. So whatever the value which you are getting, that you need to substitute here, and you need to find out the S suffix k. How many numbers of k value? That much amount of S value which could be find out from the step number 4. In the step number 5, find the that is denominator value of the transfer function h of s. Here it is the denominator value. If suppose k value is till 2, it repeats means it starts from 1 and 2, then k value extends, that is s suffix 1 you may obtain as well as s suffix 2. So it could be substituted here s minus s1 into s minus s2. It repeats till n value, that is order of the filter value. This is the denominator of transfer function. Then for finding out the numerator value of h of s, step number 6 may be adapted. So the numerator of h of s depends on n value. If the n value is odd, that is order of the filter n value is odd, substitute s equal to 0 in the denominator polynomial. Here the s value should be substituted as 0 in the denominator polynomial and find the values. This value is the numerator. If suppose you are substituting s value in the denominator values, then whatever the constant that could be multiplied, and that value is your numerator value. Whenever the n value, that is order of the filter n value is even number, then substitute s equal to 0 in the numerator, that is denominator polynomial. Substitute s value in the 0 in the denominator polynomial, and whatever the constant you are getting, in the constant you need to divide it by square root of 1 plus epsilon square. Epsilon which we could have find from the step number 1, or here also you could able to find out the epsilon value. After substituting s equal to 0 in the denominator polynomial, whatever the constant you are obtaining, that you could able to divide by square root of 1 plus epsilon square. This value is the numerator value. So finally the overall transfer function h of s could be obtained from numerator divided by denominator value. So this is the overall analog transfer function obtained from the Chebyshev filter design problem. Chebyshev filter design problem.